we are carrying on today. What are we doing? We're still carrying on with number patterns. Not something new to you guys. You should all be relatively familiar with this concept. If you weren't here on Tuesday, you might be a little bit lost, but go ahead and watch the recording and you can ask questions here if you're still very lost. So what are we doing now? We are learning how to, man, please don't remind us about our June exams. You guys are gonna do great. And then Umar asks about his background. I can't see it. Oh, it looks violent. It looks very violent. Um, cool. Yes, what are we doing? We are learning that we can represent number patterns in different ways. And so the first way we're going to look at today is we are going to look at flow diagrams. You might also know them as spider diagrams. Yeah, something we've been doing for a very, very, very long time. So something like this shouldn't look new to you. What is new, though, is the concept that this actually creates a number pattern. Because remember, what did we say a number pattern was? It was repeating a rule to get from one term to the next. And look at what happens when we do a flow diagram. Can you see we have rules in the middle over here? And so what do? We go from our left side, we repeat our rule every time and we go and we get the outputs on our right side. So a flow diagram actually can create a number pattern for us. And so this is one of the ways that we can represent number patterns. And so if we look at this, what is our rule? Here we have our rule is +4 and then multiply by 2. And so what you should know is in a flow diagram, we have what we call inputs. We have our rule. I don't know why my handwriting looks like I'm in grade 2 today, but whatever. And then we have our outputs. Okay, so we have inputs, we have a rule in the middle, and then we have outputs. So it's almost like a machine. Think about it, guys. You put something in the front of the machine, it goes through the conveyor belt, stuff gets done to it in the middle. That's our rule. And at the end of the machine, it comes out as a finished product, and that is our output. And so that's how a flow diagram works. To relate this more to maths now, and I really want to rewrite this so that it looks somewhat decent. Inputs. To relate this to maths, we call our inputs our x values, and we call our outputs our y values. So all that it means is that these values over here are different values for x. And depending on what my x value is, I am going to get out a different y value. Based on just this little bit of theory we've gone through now, do I have any questions? You can give me a thumbs up if you're okay, or you can raise your hand if you have a question to ask at this point in time. Handle, thank you. Okay. I'm not seeing any hands raised, so I'm assuming we're all happy and good and understanding this concept of inputs, the rule, and then the outputs. We apply our rule to our inputs, and that gives us our outputs. So let's have a look at how does that work. I have to go and I have to calculate my first output over here. How do I calculate my first output? I take my input, and I plus 4. Can somebody tell me what is -3 plus 4? Don't forget, we're dealing with integers here, so be careful when you do that. 100%, Tando, it is 1. Why? How did I get 1? Remember, if I had to do a number line, oh my gosh, that's the skewest line I've ever seen in my life. Let's try that again. There we go. If I had to do a line, right? And let's just say this was 0, I know on the right, I have all my positive numbers. And on the left of my 0, I'm going to have my negative numbers. -3, -4, -5. And so, how does this work? We start at -3, and then I am doing addition. And remember what we spoke about on Tuesday. When you're doing addition, which way do you go on the number line? You go to the right when you are doing addition. So I'm going to jump 4 spaces to the right. 1, 2, 3, 4, and I end up at 1. So that is how I got 1 over there, okay? Now that I know that's 1, I have to multiply that by 2. 1 times 2 is going to give me what? 2. That's a lot of 2s. You never actually got how to use a number line. So I hope it makes sense now, Bree. Number lines are great. Number lines like chef's kiss, 10 out of 10, would recommend. Yeah, they are super, super helpful when you don't know how to add your integers. And once you start using the number lines, you'll see you get so used to using the number line that you can even just do it in your mind after a while. So that's it. And that's how we get now my output is going to be 2. I hope that everybody is happy with that and everybody understands that. Let's go to our next one, 2, 6, 8, 16. We will see if you are correct. So then my next output, let's look at how we're going to do that. My input is -1. I have to apply my rule to -1. And so to apply my rule, that's going to be +4. -1 plus 4. Let's have a look at how we do that. So let's clear my number line. I start at -1 over here. When I do addition on my number line, I need to move to my right. So let's move 4 blocks to the right. 1, 2, 3, 4. I end up with 3. Yes, and I see everybody had the answer in the chat. So we have 3 over there, and then I have to multiply by 2. So that is going to give me 3 times 2. Answer is 6. Good job, everybody. Let's go to my next one to calculate 3. What is my input? My input is 0. 0 plus 4 is going to be 4. That's a super easy one because I'm not dealing with negative numbers there. So 0 plus 4 is 4 times 2. That is going to be 4 times 2. That is going to be 8. And last one, let's see. That would be number 4. Okay, and then we have 4 plus 4, which is going to be 8. Again, not difficult because it's just positive numbers. And that's going to be 8. And then I want to multiply by 2. And we are going to get 16. Okay, I hope that this makes a lot of sense and that we're all having light bulb moments and that we're like, oh, this is easy. This is not so bad. If you have any questions about how I got any of these answers, please feel free to answer. And then we move on to our next one. I kind of want to go, no. I want us not to look at the next one. So let us deal with this. Also, if anybody wants to help me with this one, that would be great. So I just want to mark, these are my X values. I'm going to look for my Y value. And this is my rule. Let's understand what is my rule. I need to multiply by 3 first and then -1. The other thing I want you guys to see is when we're dealing with a flow diagram, the order in which we apply the rule is very important. If I were to do this previous one up here and I multiplied by 2 first and then +4, I would have gotten different answers. So remember, like I said, think of it as a machine. It's going on the conveyor belt. The first block is the first thing that's going to happen to whatever is on my conveyor belt. So I can't go and let it go past -3 and then go to -1 and then reverse back to ×3. No, that's not how it works. Think of it as that machine. It goes on the conveyor belt, ×3 first, then -1. And then we have our final product. Okay, and Uma is super fast. Let us have a look at it. So I have number 1 over here. Let me calculate this for number 1. My input is -2. I then have to multiply by 3. It is -6. Thank you. -6 and then -1. Correct. So -6 minus 1. And what is -6 minus 1? -7. 100%, guys. Thank you for that. Let's look at the next one. Oh, and let's write in my answer here, -7. For number 2, I'm going to go -1 multiply by 3. And remember, guys, how do I get this answer? It's a negative multiplied by a positive. And that is going to give me a negative answer. And so now that I know what my signs are doing, I can just go 1 times 3 is 3. And then I still need to minus 1. And -3 minus 1, how do I know that? That's confusing. I don't know. Oh, here we go. Here's my number line. Let's go back to my number line. I am going to start at -3, and then I need to minus. And because I'm minusing, it means I have to move to the left on my number line. And when I move to the left, I'll see my answer is going to be -4. Answers in the chat. You guys are brilliant. And that's going to give me -4, -4. Then number 3, hi Emihle. Number 3, what are we doing over here? I am going to do my input. Let's see, what is my input? My input over here is 1. So that's going to be 1 times 3. And I have to minus 1. That is going to give me 3 minus 1. And that is 2. What are we doing? We are showing how we can represent number patterns using flow diagrams. So we're carrying on with number patterns. We are showing how they can be represented using flow diagrams. Okay, and then last one, we have number 4. Do that. What is my input for number 4? It is going to be 3 times 3, and then I have to minus 1. And so that is going to be 9 minus 1. Valentine, super fast and correct. 8 is the answer. Now, what you guys might be saying is, I understand this, but how is this a number pattern? If you recall, when we did number patterns on Tuesday, do you remember me telling you guys that when we have number patterns, we have term numbers? So we have my number pattern, and then I can number each one of my terms. So what this diagram is actually doing is all of these inputs, my inputs, are actually my term numbers. And my outputs are actually getting me my term value. Now remember, there's a difference between the term number and the term value. Say, for example, think of a class list. It's a fairly decent example for you to think about. Think of a class list. If you are number 10 on the class list, that is your number. But your name is not 10. Your name is whatever your name is. So if I'm number 10 on the class list, my number is number 10, but my name is Simone. And so here, my term number is just the number in the pattern. What is the number of this term in the pattern? And when I get to the term value, it's telling me what is the value of this term? What is the number that is actually associated with the term? What is the name? What is my name? My name is Simone. My number on the class list is 10. Last on your class list. Yeah, so that's how you think of it. This is how we can represent number patterns. So if I were to ask you for term number 1 up until term number 5, you would make your inputs on the flow diagram 1, 2, 3, 4, 5, and your outputs would then be your number pattern. And then if I ask for that same number pattern, give me the 50th term, your input, you would go ahead and put in 50, and your output would give you the 50th term, the value of the 50th term for that number pattern. Are we all clear on this? With these two flow diagrams that we've done, can I get thumbs ups and also on how this is a number pattern? Some thumbs up or questions? I see a thumbs up. Thank you. There are 29 of us in here. I'm seeing 1 thumbs up. Is everybody okay? I'm glad that the examples help. Okay, there we go. We have some thumbs ups. No questions, I'm assuming, because I don't see any raised hands or questions in the chat. So now that we know this is how we can represent number patterns. Okay, Emitle, don't worry. You can go ahead and catch up with the recording. When the recording is out, just go and watch the beginning of the lesson. You'll see it all starts to make sense. But sorry, I was reading the chat. It also all start to make sense when you go and catch up on the recording. But also, as we do more examples, you'll see how we're doing it. All that I'm doing is I am using a flow diagram to represent my number pattern. How do I do that? With my number pattern, think about a number pattern. If I have a number pattern 3, 6, 9, 12, how does this work? This is actually going to be term number 1, term number 2, term number 3, and term number 4. I can represent this pattern using a flow diagram. What is my rule over here? My rule is plus 3. Plus 3. So you'll see the rule is plus 3. So in my flow diagram, I'm going to give my rule. I can then, let me move this. I can then use my flow diagram to represent my number pattern. How is it plus 3? I'm going from 3 to 6. How do I get from 3 to 6? I have to add 3. How do I go from 6 to 9? I have to add 3. So we can see the common thing that I'm doing to get from one term to the next is adding 3. And so if I do my inputs and then I have outputs, my outputs is going to give me my term values. What are my term values? My term values are all of these numbers over here, which you can't see anymore because I went and highlighted on top of it. Yeah. Anyways, let me erase this so we all can see. Those are my term values. So my outputs are going to give me the term values. My inputs is going to be my term numbers. So if I put in my input as 1 over here, my output is going to be 3. Oh, no, guys. Let me not do that. My number here, my flow diagram is actually going to be plus 3 and then minus 1. And I'll explain. I know you're going to be like, man, where does this 1 come from? Where does minus 1 come from? You'll see in a second where the minus 1 comes from. So if I have my input over here as 3, 3 plus 3, what am I doing? Term 1. 1 plus 3 is going to be 4. 4 minus 1 is going to give me 3. And so 2, that's going to be 6. 3 is going to be 5. And 4, guys, sorry, I'm not paying attention. And that is going to be 12. So this is how I've now taken my number pattern and I've used a flow diagram to represent that. And you'll see, I'll show you guys now how you know what your rule is over here. And I think that's what you were asking, Brie, how is it +3? So you were not talking about this rule over here. You were talking about the number in the middle. I'll tell you now how you can get to this rule over here. And so this is how we use flow diagrams to represent our number patterns. And so here in my flow diagram, I have my rule is +1 times 3 divided by 2. And so what I want us to do is I want us now, let's look at how do we know what my rule is. If I go back up here, what I want you guys to see is what if my input over here was y? Let's say I had an input of y. What is my output going to be? Well, let's look at it, right? My input is going to be y. Yes, immediately.
Evening, ma'am.
Evening.
Ma'am, I just want to ask if you may please explain the term values and term numbers.
If I can explain the
term numbers and term values, like
okay, give me a second. Okay, term numbers and term values. So I want to go back to where I had my number pattern. Let me start over. Let's start over. So I'm going to erase all of this. So, Emisa, do you want to give me a number pattern?
okay, 12, 24,
12,
12,
24,
24,
36, I think I heard.
yes, 36.
Okay. Now, this is my number pattern, okay? But think about, and I don't know if you were here when I gave the example of the class list. Think about a class list. Your class list has a list of all of the students' names in your class. And so this is basically my students' names. Now on the class list, you also get assigned a number, right? So this is going to be term number 1. This is going to be term number 2, and this is going to be term number 3. So when I say term number 3, it just means I'm asking for the value of the third term in the number pattern. Like on a class list, when they say, okay, number 3, come sit here. Is your name number 3? No, your name is not number 3. Your name is Emihle. So I like to think of my term values as names on a class list. So think of it as the names that they give you in your class list. And then my term numbers. So term numbers is the number that you are assigned on your class list. It has nothing to do with you or anything. It's just the number that you have been placed on that class list. And so that's what it is with a pattern. The number that this term over here has been placed in this pattern is number 2. It's been placed second in the pattern. And so that is the term number. My term number is number 2. Does that make sense?
Yes, ma'am. Thank you very much, ma'am.
Pleasure. And so back to this, guys, I was saying, if we have y as an input over here, what is my output going to be? Remember, my input, I have to apply the rule and I get my output. So, and let me actually not make this y. Let's make this x, okay? Because remember what we said, we knew that my inputs we label as x and my outputs we label as y. So because I know my output is y, I'm looking for y. Now y is going to be equals to, x, because remember, to get my output, I take my input, I have to apply my rule, and I get my output. So I took my input, I applied the rule, and that's going to give me my output. And so what you'll see is we actually now have got an equation, and I can simplify this to y is equals to 3x minus 1. And so now you will see how this makes sense in terms of if I had to have a pattern and then put it into a flow diagram, you can see how did this happen? How did they get this rule over here? They took the equation that they had. They said, okay, what were we doing to our input? I'm multiplying my input by 3, and then I'm minusing 1. Yes, this is very similar to functions and relationships. And so this might not make sense to you as yet, but let's go ahead and let's look at this next one. So over here, we have a new, we have a new flow diagram. Let's look at it. Now remember, we call our inputs our X values. We call our outputs our Y values. And so I want to add another one in here. What if I had an input of X? What is my output? I know is going to be Y, but let's see how do I get Y? And so let us look at that. So let's go number one. Number one, I'm taking my input. I am going to add 1 to it. -5 plus 1 is going to give me -4. So that's going to be -4. Then I need to multiply by 3 and then divide by 2. And remember, guys, we can use BODMAS as well. So that's okay. So -4 times 3 is going to give me positive times a negative is going to be negative. 4 times 3 is 12 divided by 2. Negative divided by a positive, -6. Everybody understands that? Okay, Uma, I see you got the answer. I'm thinking the skull is maybe because it was hard. Okay, so thank you for that thumbs up, Tando. As long as we're getting this, that is super good news for me. So we have 0 plus 1, then I have to multiply by 3, divide by 2. 1 times 3 divided by 2, that's going to give me 3 divided by 2. And can somebody tell me what is 3 divided by 2? 1.5. So we can go 1.5. We can go 3 over 2. Or, yeah, 1.5 or 3 over 2. That's that. So let's go 1.5 over there. Let's calculate number 3. Oh, you had skull on your keyboard. Okay. 3 plus 1. And then we want to multiply by 3, divide by 2. 3 plus 1 is 4 times 3 divided by 2. 4 times 3 is going to be 12. And that's going to give me 6. Oh, no. 6 over there. Oh, and nobody told me. I missed my negative over there. And then let's look at number 4. To get that one, I'm going to say 7 plus 1 times 3 divided by 2. That's going to give me 8 times 3 divided by 2. 8 times 3. Anybody want to tell me what is 8 times 3? 24 divided by 2 is going to give me 12. And that is going to be 12. Now, remember, my inputs are X, my outputs is Y. So how do I represent this in an equation? Well, if I take my input and I apply my rule, times 3 divided by 2, that is going to give me Y, right? And so I don't like this format, so I want to move my Y over to this side. And then let's see. I have x plus 1, okay? And then I'm going to multiply by 3 and divide by 2. So what I want to do is I can say x plus 1, and then I want to divide that by 2 and multiply by 3. Does this make sense? Does everybody understand how I got this answer over here? A little bit of a tricky one, but remember, I have to know it doesn't make sense, okay? Remember what we're doing over here is I'm taking my x plus 1. I have to plus 1 first. So I can't separate my x plus 1. So let me erase this. I have to take x plus 1. So I have to have x plus 1. We know that has to be in brackets. And then, because I'm doing BODMAS, I can multiply by 3 and then divide by 2. Either which way, it doesn't matter the order in which I do it. And so, and in case you're confused about why I'm saying it doesn't matter the order, remember with BODMAS, BODMAS, whenever we have division and multiplication, we can change the order of that only if it is division and multiplication. And the same with addition and subtraction. When we are dealing with division and multiplication only, we can work from left to right. And so over here, what we're doing is I'm saying, if I had to multiply this by 2, and then I have to divide it by 3. Does this format make more sense to you guys? I took x plus 1, I multiplied by 2, and I divided by 3. Remember, I said this fraction doing this, is saying same thing as saying 1 divided by 3. So what I did here is I said x plus 1, I and I'm doing the wrong numbers, but you know what I meant. Multiply by 3 divided by 2. So Tando is saying yes. Okay, Itandile is with us. Also, Bree, isn't y equal to 0? Y equal to 0 for which one? For number 1, 2, 3, 4, or for this one? For this one, we can't really get a value for y because we're dealing with variables. I don't know what the value of x is. Okay, and so instead of putting this multiplication by 3 on the top over there, all I did is I just did multiplication by 3 like that. So Bree, y cannot be equal to 0 because I don't know the answer to x. If I had a number over here, maybe I could calculate. But because I have a variable over here, I can't actually use any numbers to calculate anything. So this is this, guys. Put in your x into your flow diagram. Apply your rule, just like we did with any of these other things. And then once you've applied your rule, move it around so it makes sense mathematically until you get an equation. And so here my equation is y is equals to x plus 1 multiplied by 3 divided by 2. And so that is how I got that. And we're going to do a brain break now because I'm seeing some thumbs ups. After the brain break, we're going to look at a new way to represent these number patterns, and hopefully it'll all tie in together and you'll see why are these equations important. Cool. Brain break time. I'm sure everybody is tired. I kind of get it. That's a start immediately, especially because you were late. So we are playing One Must Go as usual. If you had to get rid of one, Isandile, I can't stand by you. I cannot stand by you and your decision to get rid of 30 seconds. Yes, so 30 seconds. I love 30 seconds. Same. Umar?
Ma'am, I
Mm-hmm.
played 30 seconds before. I've played Monopoly. I've played Uno, but I haven't played Cluedo or whatever that thing is. So
Mm.
I have to get rid of it.
Okay, I didn't play Cluedo up until like maybe like a couple of years ago. Okay, maybe like 5 years ago. But it's actually really fun. It's really, really fun. I like it more than Uno. So for me, I'm getting rid of Uno. Sorry.
Oh man, why Uno?
Because like I really like 30 seconds. I think it's so fun the like explaining and then it's like you're laughing because your partner doesn't get it. And then Monopoly, that's Monopoly. When you have siblings, all you want to do is beat your siblings. And then Uno, I used to play it a lot, guys. Like at school, primary school, those were the days everybody used to bring Uno cards to school and we used to play Uno all the time. I got bored of it. Pluto is a recent game. I also started playing it recently. I say recently, but again, like 5 years ago. But yeah, it's super fun. It's really, really, really fun. It's like a mystery. It's literally a murder mystery. It is a murder mystery. So yeah, I think that's super, super fun. Yeah, everybody wants to keep Uno. Sorry, Brie. I mean, Uno. I got so tired of it, guys. I can't. Next one we have, and this is just brands, guys. It doesn't have to be shoes. Obviously, these brands are just known for shoes, so I put pictures of shoes in. But Adidas, Nike, Converse, if you don't know what is New Balance, New Balance is like, these dad shoes that everybody likes nowadays. Yes, yeah,
Ma'am, New Balance, ma'am, has to go, ma'am. Because I
I
don't even have them,
agree.
ma'am, but they have to go, ma'am. Because I feel like nah, they're not the ones.
I agree. Thank you, yeah. No, I feel like nobody has said that as yet.
Yes, ma'am.
So you have all of the other shoes.
Yes, ma'am.
Oh my word, not even I have. I have only Nike and Converse. I don't have any Adidas. I also don't really like Adidas that much. Like I don't know.
Man, I have to
Yes,
go with New Balance.
same. Why? What's your reason?
Because Adidas and Nike are sports shoes.
Mm-hmm.
Converse, I really don't know. New Balance doesn't look right from the picture. Doesn't look right.
But this is like the new trend that's in. Haven't you seen like everybody's wearing these like dad
Nope.
shoes?
The only thing I'm watching is traumatizing animes.
Yeah, if you go like anywhere on Instagram, literally go to any fashion person's Instagram, they are wearing these shoes.
On Instagram, I watch Mike Tyson.
Oh, yeah, I don't know anything about Mike Tyson, so you
Man, there
please
should be
can't
one part for boxes. Mike Tyson, Jake Paul, Muhammad Ali, and all of those boxes, man. And one
uh
has to go.
see, I would, right? But because I do these myself, I don't know. I wouldn't even know which fighters to put in, you know? Converse are ugly. That's so not true. Hey guys, this one was a weird one. I don't think any of you really would care, but I thought it was interesting. I just thought of it randomly. Pick and pay, what? Guys, why is everybody saying pick and pay? I'm saying spa. Like, who shops at spa? I've never, okay, I have shopped at spa. But like, spa is weird. I also feel like spa is weird. Like, I have pick and pays near me, I have checkers near me, I have Woolworths near me. But like, spa is like just such a random shop to me. Like, it's just so, it's so random. Spa is expensive. So if you shop at Spa, you can't be called poor. Spa is expensive. Um, yeah. I'm saying Spa. Sorry. Woolworths, I can't get rid of Woolworths only because checkers. I can't get rid of Woolworths only because I really like their desserts. Like you can fight me on this, but nobody makes desserts like Woolworths does. Like cakes, puddings, mousse, anything dessert, Woolworths is amazing. So yeah, I wouldn't get rid of Woolworths just because of that. I don't know what politics is surrounding Woolworths. So I don't know. Also, guys, when I did this one, I don't know what movies you guys are watching. I really don't know what movies you guys are watching. But yeah, so I already know what you're gonna say.
Oh, ma'am, now what am I gonna say?
You're gonna say Star Wars. I know.
True facts, ma'am. Yes, ma'am. Ma'am, I actually was gonna say Star Wars, ma'am. Star Wars, nah. Yeah, it's not the one.
Have you watched it?
Yeah, I have, ma'am, but nope. It's not for me.
Okay, you're better than me. I haven't watched it, not one.
Mm.
Yeah, so I'm with you there. Star Wars, yeah, not it. Bree?
Hi everyone. Personally, I'll get rid of Fast and Furious. There's no way I'm letting go of Transformers, Star Wars, and especially Harry Potter. I love Harry Potter so much. There's no
Bree?
way.
There is no way. You said you're getting rid of Fast and Furious.
Yeah, I'm not a fan of those kind of movies, so I'd
Oh
rather
my
stick in my
word.
fantasy world.
Okay, that makes sense. I see. Yeah, it's actually, now that I think about it, it's like the only one that doesn't fit into like the fantasy theme. Yeah, okay, valid point, valid point. Let's see what Emilia has to say.
Ma'am, out of
Mm-hmm.
all four of these movies, I would take out Star Wars. I've only watched like a bit of a Star Wars movie, and I found it so boring. But like um Fast and Furious should not get rid of, man, because even though there's like I
And
think there's 10, right?
mm-hmm.
I think they should continue with them, man, because they're really nice.
Also, I love it. I've watched the amount of times I've watched Transformers and Fast and Furious is actually crazy. Like, I think I've watched every single one of them at least like 5 times. Um, Fast and Furious, yeah. What are people saying in the chat? Star Wars, Harry Potter. I also, guys, don't kill me, but like I also haven't really watched all of the Harry Potters. I haven't watched all of the Harry Potters. Anyways. Harry Potter is weird. I also thought so, right? But I only thought so. Like when I was small, it was playing on SABC2, guys. Don't judge. But it was playing on SABC2 the one time, and I like went in it. And the first thing I saw was like a bunch of spiders all over. And I was like, no ways. I was like, no ways. Because yeah, when I saw that on SABC2, like way back when, I didn't watch it. I did not watch it. I refused to watch it until like a few years ago, maybe 2 years ago. I was like, okay, let me give this thing another chance. And then I watched maybe like the first three. And yeah, that was it. That was it for me. Okay, guys, moving on to work again. Let us go. We are now looking at tables. And a table might make a little bit more sense to you guys in terms of term numbers and term values. So all of my inputs over here are my term numbers. So these are my term numbers. And my outputs is what actually represents the actual number pattern itself. So my term values over here. Term values. And so if we have a look at this, my pattern goes 3, 2, 1, 0. I think we can all see where this is going. So let's answer A. Describe the pattern in words. Does somebody want to tell me? You can type it in the chat or raise your hand. But describing the pattern in words is what we did on Tuesday. Yes, immediately.
Ma'am, the pattern is -1 to get to the next term.
100% -1 to get to the next term. And thank you, Uma, for putting that in the chat for us as well. -1 to get to the next term. Cool. Fill in the missing input values of 5, 6, and 7. So, and this is actually wrong. I'm not, it's fill in the missing output values for 5, 6, and 7. Uma, super quick. Yes.
For number 5, it's going to be -1. For number 6, it's going to be -2.
And I see somebody answered in the chat. -3. Thank you, Uma. And thank you everybody in the chat for that. Yeah. Now for X, what is my output? If my input is X, my output is going to be Y. But how do I get Y? How did I know this was going to be Y? How do I take X and apply my rule to get Y? We're going to have a look at that now. So we have filled in the missing values. Now we want to determine an algebraic rule for the pattern. And so now we have, that's okay, Uma, somebody is unmuted right now. So please just check yourselves and mute yourselves unless you have something to contribute. When we're looking at C, when we talk about an algebraic rule, it's something that's going to look like this. This over here is an algebraic rule. Algebraic just means algebra. Use algebra to give us a rule. And so how do we get an algebraic rule using these tables? And this will also help you when you have a number pattern, how to get your rule. And then once you have your rule, you can make yourself a nice algebraic rule and put that into a flow diagram. So how do we do that? What we do, step 1, is we take what we add or subtract in the pattern and we multiply it by my input. Okay. Step 2 is then you see what do I need to add or subtract to that product. And now what product am I talking about? I'm talking about this product here. When I multiply by my input, I see what do I need to multiply, what do I need to add or subtract to my product to get my output. Okay, so let's look at this. How am I going to start? I'm going to start by saying, what am I doing each time to get to my next term? And we already said we are minusing 1. So if I apply step 1 is I need to take what I'm adding and subtracting and I need to multiply it by my input. So that means it's going to be -1 multiplied by what's my input? X. And that is going to give me -x. I hope that makes sense to everybody. I'm just following the steps. So I've given you rules. I've given you steps to do how to find an algebraic rule. And now we are just following the steps. And now to follow step 2. Sorry, but is the quiz out yet? It should have been out about 4 minutes ago. It should have been sent out. And so if we have to apply step 2 now, how do I apply step 2? I am going to go ahead and go, okay, if my input, let's just say, let's look at this. I have an input of 1 and an output of 3. So if I have -1 as my input, I want to get my output of 3. what do I have to do to -1 to get to 3? Can somebody tell me? I have -1 plus something must equal to 3. Immediately?
Ma'am, you -1 plus 4, ma'am.
Plus 4. So that gives me now, I can now look at my rule and say, okay, that means to get to y, I take my negative input and plus 4 to get to my output. Are you seeing that immediately? Does that make sense to you?
Yes, ma'am, it does.
It does make sense. So -x plus 4. And so whenever we get a rule, whenever we find an algebraic rule, what we always want to do is we want to check our rule. So let's go and let's check this rule. I said my rule is that y is equals to -x plus 4. Okay, that's fine. Let's pick an input and an output. Over here, I know my input is, and my input is x, and my input is 6, and I know that my output that I should get is -2. Okay, and so let me do that. So that makes more sense. And so let's check if this rule works. I'm going to say y is going to be equals to negative. And what's my input? My input is 6 plus 4. -6 plus 4 gives me what? -6 plus 4 gives me -2. Thank you, Tando. And now that I have this -2, I see, okay, I've now calculated that my y is going to be -2. Ma'am, what's with the blank spaces? Blank spaces where? Let me just see who's unmuted. Sorry. There we go. Gray blank spaces. Oh, don't worry about that. It's just showing that it's not now giving, it's skipping those places in the pattern and moving on to X. So it's not going in order anymore. Okay, and so now that we see, okay, this rule does work because when I put my input in, I get my output the way I'm supposed to. And so now that I know this rule works, what we want to do is we want to now go and draw a flow diagram to represent this pattern. And now that I have my rule, it's actually super easy because I know what do I have to do now. And I'm going to do a circle because I know if I try, please can I see the first step? The steps are still on the board, Itandile. So if you have a question and you're not understanding, maybe you can ask about that. Now that I have my rule, it's actually easy for me to see what I have to put as my rule in my flow diagram. My rule over here, look at what we're doing to X. We are making it negative. So that means I have to multiply by -1. And then what am I doing? After I multiply by -1, I am then adding 4. And let's go and let's try and test this flow diagram. So we have 1, 2, 3, 4. So let's put in these inputs. 1, 2, 3, 4. 1 times -1 is -1. -1 plus 4 is going to give me 3. And let's go back up. Can you see I got the correct output? And if you apply all of that, you will see 3, 2, 1, 0. Give me a thumbs up, thumbs down that this makes sense and that we now know how we can take a pattern, get a rule, put it into a flow diagram. Yay, I'm seeing thumbs ups. That makes me so super happy. And